Alright, let's go ahead and finish off the factoring material with equation solving. Let's use factoring skills to solve equations, to solve polynomial equations through factoring, because these equations are more complicated, so we cannot simply get x on one side, numbers on the other side, as with the linear equation as in the past. So let's take a look at this concept, these concepts here in this section. So let's go and look at solving equations by factoring. Alright, now before we get into that, let me give you a little word prompt to sort of motivate the topic just a little bit here. Alright, so let's take a look at this word prompt, which we're going to need to set up an equation, and then it will involve factoring when it comes to solving it. Alright, let's take a look at this prompt. Alright, so here's the prompt. Let's suppose the length of a rectangle is 7 feet more than the width. If the area of the rectangle is 60 square feet, find the length and width of the rectangle. So pretty basic area prompt, right? So first off, we're going to make a rectangle. All right. So it says what the length of the rectangle is 7 feet more than the width. So let's call the width here. Let's call it x, since we don't know what it is. We do know the length is 7 feet more than that. So let's call that x plus 7, as we clearly see that. Right? Now the area of the rectangle is 60 square feet, so the area here is equal to 60 in this problem. All right. So we want to come up with an equation for that. Now, obviously, we need to know what the area formula is for rectangle, and to recall that from geometry or from the past experience, then this is going to be length times width is area. All right, length times width is area. So again, area of a rectangle is length times the width. So therefore, I can just simply multiply these two expressions here. So I'm going to have x times x plus 7 equal to the area of 60. Alright? Now the question here is, how do I go about solving this equation? Well, factoring skills are going to be involved in solving this equation. Alright? So let's get back to this problem later on, because I want to get into the main concept of solving equations by factoring here before we get into this word problem. Right? So let me go ahead and clear off the screen and talk about the zero products principle, if you will. Let's look at what's called the zero products principle. Zero products principle. Okay, zero products principle. What does it say? Well, it says the following. So zero products, right? That means if I have two numbers, so let me say if two numbers, let me say it this way. If A times B is equal to 0, if I have two numbers A and B, right, and their product is 0, then what's our conclusion here? Well, then we can safely conclude that one of these numbers have to be what? Have to be 0. Can we see that? Again, zero products principle here. If the product of two numbers, A and B, are the product of two factors, A and B, if their product is 0, then one of them has to be 0. Otherwise, how can they multiply to 0? If they're both, if A and B are not 0, they cannot multiply to 0. Can we see that? That means if they multiply to 0, that means one of them has to be 0. So the conclusion is that either what? Either A is equal to 0 or B is equal to 0. Can we see that? So one of these numbers have to be 0. That's what we're saying here. That's what the zero products principle says. So, and that makes sense because, again, if you have think of two numbers here. If they multiply to 0, of course one of them has to be 0. Otherwise, if neither number is 0, then how can their product be 0? That's impossible. Can we see that? All right. So keep that in mind. So what does that mean then? How can I apply this concept to solving equations in this section? Well, for example, let's say I give you two factors here. Let's say I give you x plus 5 times x minus 7 is equal to 0. All right. Let's say I give you the product of these two factors is, no, these are numbers, right? The product of these two numbers is equal to 0. What's our conclusion? Well, from up here, from the zero products principle, then I can say what? That means either x plus 5 is 0, either the first this is my A, right? This is my B, right? So either A is 0 or B is 0. In this case, B is x minus 7. Okay, can we see that? So again, my point is if I have two factors that multiply to 0, that means one of them have to be 0. That's what this zero products principle says. If I have two different numbers that multiply to 0, that means one of those numbers have to be 0. Otherwise, their product cannot be 0. They can both be 0, but at least one of them have to be 0. Okay? So that means either x plus 5 is 0 or x minus 7 is 0 if x plus 5 times x minus 7 is equal to 0. Can we see that? Now, notice I have two different equations here, right? X plus 5 equals 0, x minus 7 equals 0. So I can solve each of them separately, couldn't I? Here I just subtract 5 on both sides, as you know. So x is equal to what? Negative 5. Here I just add 7 to both sides. So x is equal to what? Positive 7. So I have two answers, right? X can be negative 5 or what? Positive 7. If I plug either of these numbers in, then the product will be what? 0. For example, if I plug in 7, what happens? 7 plus 5 is 12, but 7 minus 7 is what? 0. 12 times 0 is 0. If I plug in negative 5, negative 5 plus 5 is what? 0, and then negative 5 minus 7, negative 12. Well, 0 times negative 12 is still 0. Okay? So again, in this case, our solution is negative 5 and positive 7. So all we do is what? We set these factors to 0. Once I have the product equal to 0, I just set the individual factors to 0, and I finish solving each of those equations. All right? Let's try another one. Let me clear out the screen. Let's extend this zero products principle a little more. All right? Let's have some of this. 3x times 4x minus 2 times 6x plus 1 equal to 0. All right? Equal to 0. So, 0. Okay. So now I have three different factors, right? 3x, 4x minus 2, 6x plus 1, and it's equal to 0. So again, what does that mean? That means one of these three guys have to be 0. Otherwise, how can their product be 0? All right? So this means what? Either 3x is equal to 0, or 4x minus 2 is equal to 0, or what? 6x plus 1 is equal to 0. Can we see that? One of these three factors have to be 0. Otherwise, how can their product be 0? They can all be 0, but again, I'm talking about these entire numbers here, right? They can all be 0, but at least one of them have to be 0 in order for the product to be 0. Now, if I set, so again, all we're doing is what? Once I get the products here, the product of these factors, that is, I just set them all individually to equal to what? 0. And find out what x is that will make these factors 0. Okay? So here, that's not too bad. Just divide by 3 here. All right? X, so 0 divided by 3 is what? X is what? Well, x is equal to what? 0. 0 over 3 is still 0. How about this one? Well, add 2 to both sides. So 4x is equal to 2. So dividing by 4, x is going to be what? 2 over 4, right? 1/2. Excuse me. 1/2 in this case, right? 2 over 4. All right? How about here? Subtract 1 on both sides. 6x is equal to negative 1. Divide both sides by 6. So what's that? Negative 1 what? 1/6. Okay, so we have three different solutions to this problem here. Can we see that? So x is equal to what? 0, 1/2, or negative 1/6. X could be any of these three numbers, and it would make this product what? 0. Okay, can we see that? Again, the main idea for the zero products principle is what? Once we get the product to equal 0, again, it has to equal 0. If it's equal any other number, I cannot do this. All right? The product must be 0. Keep that in mind. Then I set each individual factor to 0, and I finish solving each equation. Okay? So that's not too bad. Now let's look at this one then. What about x squared minus x minus 6 equal to 0? Let's solve this equation here. All right? Well, here I didn't give it to you in factor form. But look, we know how to factor this. We saw this from the previous homework, right? That's just a standard trinomial which factors into two binomials. So we saw this earlier, right? Okay. Well, then, how does the factoring go? So you might want to review the earlier sections here, right? So x here and x here for x squared, all right? Again, I'm looking for what? Two numbers that multiply to negative 6 and add up to negative 1. Well, you think about it a little bit, the two numbers will be what? Negative 3 and what? Positive 2. Because negative 3 times positive 2 is negative 6. Negative 3 plus 2 is negative 1. All right? Again, this is the correct factoring. Again, review your homework if necessary from the previous sections. All right? Again, once we have the factoring down, we now set the factors to 0. So x minus 3 is equal to 0, or x plus 2 is equal to 0. Okay, can we see that? Set the individual factors to 0. We'll solve each one. So just add 3 to both sides. X is equal to what? 3. Subtract 2 to both sides. X is equal to what? Negative 2. All right, can we see that? So therefore, the solutions to this equation right here is going to be positive 3 and what? Negative 2. Can we see that? That's our solution here. Now, let's check our answers very quickly. I'll just check the 3 for you, and I'll let you check the negative 2 by yourself here. Let's plug 3 in for x. 3 squared. 3 squared is what? 9, right? Minus 3. X is 3, right? So 9 minus 3 is 6. 6 minus 6 is what? 0. Check. So this is correct. Same thing for negative 2. You can do the same thing when you plug in the check. All right? So the two solutions here are 3 and negative 2. Okay, so we factor it. And again, first of all, though, we have to make sure it's 0 here. Then we factor it. Then we set the factors to 0. And we finish solving. Okay, so not too bad at all. All right? Let's get back to our problem we had earlier. All right? Remember earlier we had the rectangle here. Remember we had the rectangle here, and we said what? Its length was 7 feet more than its width. So this was x plus 7. Remember that? And the area we said was what? 60 square feet, right? So, and therefore area is what? Length times width we mentioned, right? So therefore x times x plus 7 is equal to what? 60. We mentioned that, right? So let's get back to solving this equation now. Let me solve this equation by factoring. Now notice that I cannot set x to be 60 and x plus 7 to be 60. That's not correct here. Again, that only works if this number is what? 0. That's right. Excuse me. Right? Again, it only works. You can only set these factors to 0 if their product is 0. If their product is 60, for example, or any other number, you can't do that. So I need to do some algebra, right? So first I need to do this in solving this is to what? Simplify the left-hand side. Let me multiply out the x. X times x is what? X squared. X times 7. 7x. Can we see that? All right, equal to 60. All right. Now, remember, in order to use the zero products principle, I need to make one side of the equation what? 0, right? So let's zero out the right-hand side. Let's subtract 60 on both sides to make that happen. All right, can we see that? So I get x squared plus 7x minus 60 is equal to 0 now. Okay, I have 0 on one side, which is what I want. When it comes to solving a factoring, you want to get 0 on one side, in particular the right-hand side here. Okay, so let's factor this. Is this factorable? Do I have two numbers that multiply to negative 60 and add up to positive 7? Yes, I do. Yes, I do. All right. First of all, x and x here for x squared, right? So what two numbers will work that multiply to negative 60, add up to positive 7? Let's think about that. Well, if you think about it for a little bit, it will be what? Positive 12 and negative what? 5. Because 12 times negative 5 is negative 60. 12 plus negative 5, positive 7. Can we see that? So we have our solution then. X plus 12 equal to 0. Remember, once I factored, I set the factors to 0, right? Or x minus 5 equal to 0. So subtract 12 on both sides here. So let me show you the work there. So x is equal to negative 12. Add 5 to both sides. So x is equal to what? Positive 5. All right? Now, so I have two different answers here for, and x is what? X is the width of this rectangle. Now, notice the thing one thing about width. Can the width be negative? No, it cannot. So this answer here is not valid. So you can just cross this off, right? Because why is this not valid? Normally it would be if I'm just solving this equation, right? But however, I'm talking about x here, which is the width of this rectangle. The width of a rectangle cannot be negative. So therefore, negative 12 is not a valid answer. So therefore, the only answer is what? Positive 5. Okay? So in other words, we're saying the width of this rectangle is going to be 5 feet. All right, positive 5. Then what is the length then? Well, the length is 7 more than that. So that will be, what's 7 more than 5? Well, that's going to be 12 feet. Okay? So the dimensions of this rectangle are 5 feet by 12 feet, or 12 by 5 if you like. All right? So again, be able to solve these equations by factoring here. All right? Let's look at a few more. Let's go and try this one. Let me clear this out. Let's go and solve this equation here. X plus 2 times x minus 9, all right, equal to negative 24. Let's go and try that one. Okay, so what do I do here? Well, again, I need to get the right side to be 0 in this case. But before I do that, let me go ahead and multiply out this left-hand side like I did in the earlier example, right, for the rectangle problem. Okay, I have to multiply it out first. Do the same thing here. FOIL it out. You can FOIL it in your head, or you can show your work. I'll show my work, right? X times x is going to be what? X squared. X times negative 9, negative 9x. 2 times x, 2x, distributive property basically, right? 2 times negative 9, negative 18, equal to the same number, negative 24. All right? Combine like terms here, so you get x squared, minus 7x, minus 18, equal to negative 24. Again, make the right side 0. Let's add 24 then, because it's negative, do a positive to 0 it out, right? Add the same number to both sides. Okay, so I get x squared minus 7x plus what? Plus 6 equal to 0. Okay? Is this factorable? Well, think about it now. Two numbers that multiply to 6 add up to what? Negative 7. Yeah, it's factorable. The two numbers will be, well, first of all, x and x here for the x squared, right? Two numbers will be what? What multiplies to positive 6 add up to negative 7? Well, negative 1 and negative 6. Can you see that? Negative 1 times negative 6, positive 6, negative 1 plus negative 6, negative 7. Okay? So again, I factored it correctly. Now I set the factors to 0. So by the zero products principle, again, once I have 0 here, once I have the product equal to 0, I can set them to 0. X minus 1 equals 0, or x minus 6 equal to 0. Just add 1 to both sides, so x is equal to 1. Here, add 6 to both sides, x is equal to what? 6. So solutions are 1 and 6 here for this equation. Can we see that? Okay, so yeah, that does take some practice, but once you get used to it, it does happen very quickly here. Okay, let's go ahead and try another one. Let me go and clear out the screen. Let's try this one. Let's look at, let's try 5x squared minus 16x. All right, minus 16x is equal to negative 12. Let's try that one. All right, 5x squared minus 16x is equal to negative 12. All right. Again, let's go ahead and make the what? In this case, there's nothing to multiply out here on the left side. On the right side, I should zero it out. So let me go and add 12 to both sides here. Okay, that takes care of the negative 12, right? Plus 12, both sides. Okay, equation equal sign separates the two sides. All right. So what do I get then? I get 5x squared. All right. Now these aren't like terms. Don't think I can combine these. I cannot. Right? That's an x term. That's a number term. So these are not like terms. Just bring them down. Minus 16x plus 12 equal to what? 0. Okay? Good. Now let's go and factor this. Now I can factor this by what? You remember, either by trial and error or what? AC method. Okay? Now, so to take your pick in terms of the comfortability with each method. I'll use trial and error since I like that the best. So that's quicker for me. So let me turn into two binomials here. 5x squared, that's what? 5x and what? And x for 5x squared. Can we see that? All right? For the for 12, I'm thinking of what? I'm thinking of either 2 and 6 or 3 and 4. Okay? So let's see here. Let me think about this for a little bit. Let me try to put how about a 2 here and a 6 here? Is that going to work? Let's see. Well, let's see here. 2 here gives me what? What's this here? That gives me 2x. That gives me what? You get trial and error, right? That gives me 30x. So 2x and 30x, no, that's not going to work. Okay, so scratch that. Okay, 2 and 6 not going to work. How about 3 and 4? Okay, how about 3 and 4? Let's see here. 3 here. Let's see if I put 4. Let's put 4 here and 3 here. Okay, so trial and error takes a little time. You have to think about this a little bit here. All right. So is that going to work? Well, let's see. That's 4x, and that's what? 15x. Again, 5x times 3, right? 4x. So we have 4x and 15x. Can I get 16 out of that? No, that's still not going to work for me. Okay, so let's go ahead and start all over again. Okay, so I'm getting a little too messy now. Let me start over. So trial and error takes a little time here, right? That's why you got to practice this more often, right? So again, trial and error does take time. So let's go ahead and figure it out again. Okay, so let me go ahead and try this. How about if I put a 6 here and a 2 here now, okay? And 6 and 2 still gives me 12, right? So let's check that. This gives me what? 6x. Let me cross this off here. All right, 6x. And how about 5x and 2? That gives me 10x. Aha! I got it. All right, can we see that? All right, 6x, 10x, that's going to be what? 16x. Can we see that? I want to get 16x. 6 and 10, I can make that happen now. Now, to make that happen, though, what I need? I need both of them to be what? I need negative 6x and a negative 10x, because that will give me negative 16x. All right? There you go. Good. Challenging problem, right? So, and again, why is it challenging? Not because of the algebra, because of the factoring, right? So I'm using trial and error. Maybe I should use AC method here, right? Since I was having trouble with that, right? So again, you just have to get some practice at it. Okay. So I want 6x to be negative. So there's my 6x. It should be negative. I want the 10x to be negative. Here's my 10x right here. 5x times 2, right? Negative. Okay. Good. There it is. So let's set it to 0. So 5x minus 6 equal to 0. Or x minus 2 equal to 0. All right? Let's go ahead and solve for x in each equation. Add 6 to both sides here. All right? So 5x is equal to 6. Dividing both sides by 5, x is going to be what? 6/5 as one of the answers. Here, add 2 to both sides. Here, we get x is equal to what? Positive 2. No big deal. So my two solutions for this problem will be what? 6/5 and what? Positive 2. Okay, so again, challenging problem though. Again, why is it challenging? Not because of the concepts in this section, because of the factoring concepts from the previous section. So you might want to review that. Either AC method or trial and error. I used trial and error. It took me a little time, but I finally figured it out. Okay? So again, get some more practice on this on the homework here. Let me give you some problems to post these solutions to in Blackboard here. So let's go ahead and clear out the screen here. All right? So let's go ahead and solve the following problems then. And post these solutions into Blackboard here. All right? Let's look at 4x squared. 4x squared minus 25 equal to 0. Okay? Factor this. Difference of squares. Hint, hint. All right? And then finish it off. Okay, let's try the next one here. Let's look at 2a squared minus 9a minus 5 equal to 0. Okay, let's go and look at that one. And lastly, let's look at this one here. Let's look at y times y plus 8 equal to, let's make it equal to negative 15. Okay? So again, post the solutions to these three questions in the discussion area in Blackboard, and we'll go over the problems in class. Okay, so again, until next time then.